Morning. I'm Jeff Hammond, Executive Director at International Ground Source Heat Pump Association. Thank you for joining us for the February IGSHPA Town Hall. This town hall is sponsored by Climate Master, a manufacturer of water source and ground source heat pumps. We appreciate Climate Master's sponsorship. And we have an exciting presentation this morning with Mark Stone of Hydratech, which I'll introduce here shortly. Before we get started, I have just a few updates that I'll go through, and then we'll turn it over to our speaker. The Town Hall and Dig Deeper webinars that we do every month have information on the IGSHPA website. We are still accepting abstracts, so if you'd like to speak at one of these webinars, just go to igshpa.org and click on Training and Events. You'll find an abstract form in there, and we are also still accepting advertising for the webinars. Since these webinars are recorded, then your logo and mention is going to be there for perpetuity as long as people are watching the recording. So it's a good deal for advertising. On the 2025 conference that's coming up next month, right at about a month away now in Champaign, Illinois, we're working with Geothermal Alliance of Illinois on the annual conference. A lot of details at igshpa.org. The hotel block is completely full now, but there are other hotels in the area that are very close to the conference center. Also have sponsorship opportunities still available. Our exhibit hall, you'll see here on the next slide, is completely full, but we do have some lobbies available. And we've had some questions about getting to Champaign. The airport is relatively small, but you do have several options. You can fly directly into Champaign. Another option is flying into Indianapolis. It's a pretty short drive from Indianapolis. It's a decent sized airport, so that's a good way to go. You could fly directly into Chicago, into O'Hare or Midway. You can also take the train from Chicago if you like. So a lot of different ways to get there. Contact us if you need any help with figuring out how to make those arrangements. But there are quite a few options. We thank our conference sponsors. As you can see, we have quite a few sponsors this year, and we certainly could not do this conference without the sponsorship. So thanks to all the sponsors. We really appreciate that support of IGSHPA. This is our exhibit hall, completely full, which we're thrilled about. Lots of variety here of exhibitors. So you'll have some really good conversations with the exhibitors for 2025. We also have some heavy equipment exhibitors that are out in the parking lot outside of the exhibit hall, as well as tables. You'll see here in the blue boxes all the various tables and heavy equipment exhibitors. So this ought to be a really exciting conference. We have 52, I believe, speakers and 8 tracks. Our Geo Outlook magazine is back in publication after a little hiatus for a few years, but the January issue was just sent out the last week of January. And we're already working on July. Right now it's published twice per year. And we work with BNP Media so that we have their audience included in GeoOutlook, Engineered Systems, and ACHR News. That gives us an audience of over 50,000 people. So let us know if you'd like to write an article for the July issue or advertise. The circulation is quite good, and the archive is on the IGSHPA website. So we'd love to have your input there. If you could help us out with adding to our databases, we have 2 relatively new databases here, a project database and licensing and CEU. We need your help as local experts to help fill those databases in. If you'd like CEUs for this town hall, just simply add your email and name in the chat or in the Q&A, and we will record those for you, and they'll show up on the member portal. There's also an option for watching this later on as a recording. If you are watching this recording and you'd like CEUs, you will need this code in order to submit that. If you're live, don't worry about it. Simply send the chat or the Q&A. But if you're watching this as a recording, you will need this code. And we will be taking questions in the chat or in the Q&A. So if you would, as the speaker is going through the presentation, just simply put your questions there. I will read those at the end of the presentation, and we will be recording this session so that you can view it later on. A little bit more housekeeping here. Some people do have some security settings that make it difficult to use the chat. So you may have a box that comes up, a window like this, click OK. If you can't use the chat, you should be able to use the Q&A. If you can't use the Q&A, raise your hand and I'll unmute your microphone. But we've had pretty good success with being able to use either chat or Q&A in most of the recent webinars. I have a disclaimer here quickly, and then I'll introduce our speaker. The upcoming presentation represents the opinion of the presenter and does not represent any official position, opinion, or endorsement of any products or services by IGSHPA or its members. IGSHPA town halls and Dig Deeper webinars are for member updates and education on the latest information in the geothermal heat pump industry and are not meant to endorse one technology or brand over another. It is a presenter's responsibility to disclose any conflict of interest or position that may arise in the content of the webinar. So with that, Mark, feel free to share your screen whenever you're ready. And let me introduce our speaker. Mark Stone is the General Manager at Hydratech USA, a leading provider of innovative chemical solutions for a wide range of industrial applications. Mark leads client relations and oversees marketing efforts to tactfully align company ambitions with each customer's individual needs. With over 20 years of experience in the chemical industry, Mark brings a wealth of expertise to this role. Before joining Hydratech, Mark served as the Director of Business Development at Evans Cooling Systems, where he built lasting partnerships and drove strategic growth. His extensive technical knowledge and client-focused approach have made him a trusted leader dedicated to advancing Hydratech's international reputation for excellence. So I'm happy to turn it over to Mark. Thank you very much for presenting at our town hall. It's all yours, Mark.
Okay, thanks. Jeff, you can hear me okay?
I can hear you fine.
Okay, well, I want to say thanks very much for IGSHPA and Jeff for allowing us to spend a little time with some of your members. So without further ado, I think I'll just begin the presentation. So we're Hydratech, and today's presentation is to discuss a new, relatively new for the U.S. market, certainly, heat transfer fluid for the ground source geothermal market. As Jeff said, I'm the general manager of Liquitherm Technologies Group Limited. A little bit of an overview on who we are. So we were established back in 1998. It's a family-owned business. Hydratech is a division of Liquitherm, so we're a chemical engineering company. We provide products and commercial services globally. The core function of our company is a development delivery to support a range of unique thermal fluids and performance additives formulated to improve system energy efficiency while extending operational lifespan and reducing maintenance. So we have long-term collaboration with customers and technical partners to develop groundbreaking products. We have a full R&D department, and we have commercial partners include Agreco, BP Castrol, HD Materials Science, Empirica, Spectrum Medical, and Veolia, to name just a few. So our mission is really to ensure cooling, heating, hydronic systems gain maximum benefit from our products. We provide a range of bespoke fluid management services and mechanical equipment designed to optimize thermal physical performance at the fluid mechanical interface. So whether it's a variable speed pump, pipe, heat exchanger, or side stream filtration system. So introduction to who we are. So as I said, we've been formulating industrial heat transfer fluid since 1998. Our headquarters is in Wales, so we have a staff of 72, which includes 15 fluid management service engineers, 5 sales engineers, 2 design engineers, 2 chemists, 3 lab technicians, and a full suite of marketing department. We have operations in the US, which is the facility that I manage, Denmark, Netherlands, and most recently Spain. So we export the local supply and manufacturing facilities in the UK, Europe, and US currently. So with regard to quality, we're ISO 9001 for environment, ISO 14001 for health and safety, and ISO for health and safety and environment. So how do we bring benefits to our customers? There are many chemical companies in the world that are certainly much larger than we are. I would call them commodity trading companies. The goal of this organization has always been one customer at a time. We work with all of them And many of our customers were making custom formulations that are specific to the design of their system. So we bring fluid engineering expertise specifically associated to the renewable energy and RAC sector. So, and obviously we want to help our customers in hopes that they come back to us with the next project, certainly. Fluids. So these are our fluid divisions. It's really our product line. So Thermox DTX, that's for the cool flow geothermal ground source, air source, heat water source pump systems. We have the cool flow, which is for refrigeration process cooling and air conditioning systems. Solaris for solar thermal systems. Thermal flow for autoclave, low temperature hot water heating systems. Pure Chem, which is reconditioning chemicals to remove and neutralize various forms of contamination. And then SureFlow, which is our corrosion scale, sludge, and bacterial inhibitors. So just starting off with traditional advantages and disadvantages of what's being used currently. Probably, I would imagine the listeners here are either using methanol with regard to geothermal working fluids or propylene glycol. Propylene glycol is usually the popular choice for heat pump systems based on its non-toxic credentials. In the UK, there's actually, and I can't speak to North America, but UK, salt brine solutions are also often in use. They're selected for their heat transfer properties and because they're primarily water, have a very low viscosity. Both of those have drawbacks. PG is relatively high in viscosity, which makes it more challenging to pump. It has a lower capacity for efficient heat transfer. And then depending on the market, as in the case of in 2022, propylene glycol prices can surge quite a bit. Salt brine solutions are typically potassium formate, acetate. They have lower viscosity fluids, are exceptionally corrosive in the presence of oxygen, no matter what type of inhibitor and formulation that you have. They are particularly searching with low cohesive properties and small molecules. Basically, it's easy to leak out of every orifice, especially those around pump seals, compression joints, and manifold connections. One thing I did not put in here, and I'd be remiss, is ethanol or methanol. We do use, as I mentioned to Jeff earlier, we use ethanol in one of our formulations. It's a specific formulation for Coca-Cola, and we use it for its evaporative properties, but we really typically do not like to use ethanol. Ethanol, is probably most of the listeners know, it can be very volatile. It presents its own challenges, and I understand why some folks might want to use it because it is a lower cost than propylene glycol, but it is very volatile. You need special requirements to handle it. We need a license from the Tobacco and Firearms just to purchase it and resell it. And then lastly, one of the other diols or glycols that we were talking about is ethylene glycol. Most folks know ethylene glycol. It's generally used in your automotive applications. If you're driving a combustion engine or a car or a truck, the base of that fluid more than likely is ethylene glycol. It could be an organic acid, could be an inorganic acid. It's typically mixed with a 50-50 solution, and they're trying to protect to minus 40 degrees. It's typically not used in geothermal applications, although when I did read the EPA federal guide for geothermal applications, they do call out ethylene glycol and ethanol and methanol and propylene glycol and probably a few other substances. But it's been my experience when I have spoken to regulatory folks from various states, that ethylene glycol is typically not used. And if it is used, there's a waiver that usually has to be granted. And it's more likely, most of the time, it's not used because of the toxicity. Just with regard to the toxicity, just a little bit of food for thought. Ethylene glycol, as it sits, is really a non-toxic substance. It is only when a human being or an animal ingests it, we form toxic metabolites, which makes it us unable to process it. So it becomes toxic to us, and that under those conditions, certainly. So Thermox DTX, what is Thermox DTX? Thermox DTX is a high efficiency, non-toxic geothermal heat transfer fluid with antifreeze function for the geothermal air source heat recovery systems. So it's based on ethylene glycol. It's blended with a patented DeTox additive. Long life inhibitors provide protection against internal corrosion, scaling, and biological fouling. So this was a product that was developed many years ago by the company that I used to work for, and we were in high performance racing. And so I would travel across the country for NHRA drag racing and motocross events. We never sold it as a non-toxic formulation, but during some of that earlier development work, we were surprised through some testing that we did that we were able to actually neutralize the toxicity of ethylene glycol. And so that's where this product was really born from. So what I would say is most engineers out there recognize the superiority of ethylene glycol over propylene glycol and would prefer to use it, if I am being honest. It has a much more efficient heat transfer than propylene glycol, a lower viscosity. It trades for and sells for less costly on the open market than propylene glycol, but obviously there's a concern with regard to toxicity. So we started this in the United Kingdom. In the United Kingdom, the European Union, geothermal or ground source applications are much more prevalent than in North America. I think North America will catch up, certainly. But since 2010, we have sold more than 6 million liters of this concentrate and supplied to over 500 plus customers. Many of these are large geothermal installers for the use in renewable installations. That's an average mixture of 1 to 3. It's a 25% concentrate. And so equates to a total system volume of over 26 million liters have been installed since 2010. So does it perform better? 10% improvement or greater in COP, the return on investment and heat recovery rate due to lower viscosity, higher thermal conductivity, and reduced volume required to achieve same freeze protection. So is it safe? Lower COD and BOD compared with PG, i.e. more readily biodegradable than PG based on heat transfer fluids. BOD, how much oxygen is likely needed by bacterial decomposition of a substance in the environment. COP stands for coefficient of performance, which is the measure of how efficiently a heat pump or a refrigeration system transfer heat, especially representing the ratio of the heat energy delivered or extracted compared to the work required to operate the system. A higher COP indicates greater efficiency. And with regard to toxicity, same toxicity as propylene glycol, 15,000 milligrams per kilogram. This is an LD50. Essentially, it's a large rat population. We did this early on with the EPA many years ago. We actually are undergoing a new LD50 testing as we speak now, based on a new formulation that we have come up with. So Thermox DTX and its sister CoolFlow DTX are verified as documented as non-toxic. So it has a greater natural resistance to biological fouling and geothermal than other heat transfer fluids. And what I would also say, even if you took standard ethylene glycol, that it's toxic, and compared it to propylene glycol with regard to biodegradability, ethylene glycol readily degrades faster than propylene glycol. It does not bioaccumulate. So for the folks, the hydrologists out there who are worried about that, this product is actually safer than what's being used currently with regard to biodegradability. Is it economical? Well, I can say this, it's less costly than propylene glycol. And all one has to do is just go into Google and Google, let's say, a 5-gallon pail of inhibited propylene glycol, and then Google a 5-gallon pail of ethylene glycol, and you'll see that it's less. Ethylene glycol just sells less than propylene glycol. The good news for this is not only does it sell less, but you typically need about 5% less volume to maintain the same freeze protection than propylene glycol. So it's less costly to start with, and you need less of it. Accreditation. So this has an NSF approved for incidental food contact. It is the only ethylene glycol product in the world that has been approved for incidental fluid contact, and that's Thermox DTX and CoolFlow DTX. And so it also has an FDA approval, and that comes from a device. We have a partnership with a company called Spectrum Medical. Spectrum Medical makes a device called, of all things, Mr. Frosty. It is a device that circulates the blood during an open heart surgery. And the heat transfer medium that's in there is CoolFlow DTX. And so that we have an approval to use that. I can't really think of any more sensitive environment than that. And the fact that we're using an ethylene glycol based heat transfer fluid, I think speaks volumes to the efficacy of the product, certainly. These are associate organizations that we belong to. Obviously, IGSHPA, the Ground Source Heat Pump Association, the Heat Pump Association, VISRA, and ASHRAE. Okay, one of the things we do offer, many companies don't, is our Fluid Management Services Team program. And so what that is, over the years, especially in the food and beverage, the brewing industry, some of the systems that we supply are quite large. We did Nestle Foods, new plant in Arizona. That's a 43,000 gallon system. When a system like that goes awry in terms of biological growth or sediment fermentation or advanced corrosion or any of the issues that may plague an industrial heat transfer fluid, it can be quite costly, because for the first thing is you have to drain that system, then you have to pay to dispose of that fluid, then you have to right the system, which typically requires some kind of cleaning process, and it could be a 3-step acid, alkaline, and then a disinfectant. So it's quite costly. So we had, over the years, we would have clients reach out to us. Typically, were systems that had gone awry and asked for our expertise or assistance in essentially remediating the system. So that's where this particular idea was born from. So the way it works with this program is that if a large client or even a small client, certainly like Coca-Cola or Nestle, they basically install the fluid in the system. They collect a baseline sample. So that tells us that the fluid was installed correctly and the formulation is correct. That sample is filed away under that client. Periodically, it's typically biannually, they will send us a sample of the system, and we will look at it, and we will look at a microbiological analysis. We will look at a chemical analysis. We will look at to make sure that there's any inhibitor depletion. And what that does is it allows us to catch things very early on before it becomes a problem for the client. And we have found that has worked well for us, and certainly worked well for our customers. These are just a few of the customers that are using detoxified ethylene glycol. Some you will recognize, and some you might, because some of them are from the United Kingdom, but some of the universal brands like Coca-Cola and PepsiCo and McCain Foods and Papa John's, you certainly recognize. And some of the other ones, unless you've spent time in the United Kingdom, they might not be familiar to you. So these are beverage dispensers. We work with large pharmaceutical companies like Eli Lilly, Novo Nordisk, large supermarkets, the brewing industry, and then the chilled storage and regional distribution centers that we have supplied product for, certainly. And that's really it. I know it went pretty quick. Well, maybe it seemed quick for me. There's not a lot. Well, I would say there's certainly a lot to it, but it's just a replacement for what you're using right now. That it is more efficient and less costly. And with that, I don't know if there are any questions. I'm happy to entertain them, certainly, though.
Thank you so much, Mark. That was very informative. While we're waiting for some questions to come in the chat and the Q&A, I do have a couple questions to start off with, if you don't mind.
Sure.
I think from our experience in this industry, we've seen ethylene glycol in boiler tower systems where we have water source heat pumps and a boiler in the basement, and a cooling tower on the roof. but we haven't seen ethylene glycol in closed loop systems in ground source because of, as you mentioned, the toxicity. So this is a bit new, I think, to our industry. Can you talk a little bit about that detoxification process for people that might not be familiar with that?
Excuse me. Well, I can give you. Um, I can't really talk about the formulation, but I can
Sure.
say early work. This work was born from. We were actually consultants to General Motors, Ford, and Chrysler back in the late '90s, and we were working on a Corvette engine. And at that point, we were thinking about, at that point, what we call non-aqueous fluids, so essentially waterless fluids, because we wanted to eliminate the vapor that was trapped in the cylinder head, and that was part and parcel of the water portion of that particular fluid. During that time, we started experimenting with some mixtures of ethylene glycol, propylene glycol, and different inhibitor packages. Um, and it was an idea of a gentleman named Tom Light, who was one of the pioneers of ECS at the time, who thought that if we took some certain substances that would generally be regarded as non-toxic and mixed them in the right ratios with something that is toxic, in this case, ethylene glycol, it might mitigate or reduce the toxicity of that particular substance. So that was a theory that he had, and from that was born a series of testing. I mean, the EPA regulates that, or really dictates the lethal dose of something based on how much it takes to be, or it become lethal, a particular substance. And from that is an LG50 testing, essentially large rat populations that to establish that. And these rats are, I wouldn't say force fed, but they're given an amount that the EPA would determine as could be as toxic. And through a series of tests, they establish a lethal dose. Well, when ECS did this, they were surprised that they were able to give the dose to in this large population 3 times what would be the recommended dose in terms of toxicity, and there were no fatalities, and so that was kind of an aha moment, and and then from that later on came in vitro human tissue testing, which results mirrored the earlier LD50 testing. So that's really all I can say about it without,
Okay.
I would just say that a lot of this is covered in our patent, which is public information, but what we don't share obviously is the ratio or the formulation that
Certainly.
makes this product non-toxic, certainly.
Okay. That's very helpful, Mark. Just because it's new, I thought that might help with our audience. And we have a bunch of questions flowing in now. Jacob asks, is it flammable?
So this is just as it's no more flammable than what you're currently using now. Certainly less flammable than methanol, but it has the same flash point as propylene glycol, and it can be ignited. Certainly, in many of the applications that we're talking about low concentrations of glycol, about a 25%, 22 to 25%. Um, I would just say, because I came from the automotive, antifreeze itself is one of the least likely things to start a fire under the hood. It takes a lot to ignite antifreeze. Basically, if you took an antifreeze solution and it was to spill on a hot manifold, it wouldn't ignite. What would have to happen is it would have to flash vaporize the water portion that's in there. So you'd have to boil off all the water, and then what you're left with glycol, and then glycol could be carbonized. It could ignite. That's probably a long-winded answer, but no more flammable than what you're currently using.
Compared to propylene glycol is what you're
That's
saying,
right,
Mark.
and certainly less flammable than methanol.
Okay, thank you. Jeff asked a question. He says the HDX indicates a minimum fill of 22.5%. Is this based on the inhibiting bioactivity?
Yes. Typically, we don't at Hydratech. We get asked this a lot. Excuse me. Apologize. Usually what we're trying to do is to figure out what they're trying to protect you in terms of operating temperature. But having said that, let's say they don't have a requirement for freeze protection. The lowest concentration we typically go with for a detoxified ethylene glycol is at 22% concentrate. And propylene glycol, because we do sell propylene glycol as well. We sell, and I didn't mention, but we do sell a bio-based propylene glycol made from corn, and that is actually in this product as well. So it's that glycol, in addition to providing freeze protection, does provide some biological protection with regard to biological growth. Because in some applications, and we do use a biocide for some applications where we can, but if it is a very sensitive environment, and there may be some states that have requirements that do not allow the use of a biocide, well, you're definitely going to need to maintain a minimum concentration of glycol to protect against biological growth. A lot of the formulations that I see with regard to geothermal for the states that I'm looking at, they're typically propylene glycol. And in there, there's not a biocide that I can see. It usually has a dipotassium phosphate inhibitor package. And that's typically used because dipotassium phosphate is one of the few inhibitors that has an NSF approval for incidental food contact. So I suspect many states, when they're writing their regulations or looking at requirements, are typically just referring to a food grade propylene glycol. And in order to have a food grade propylene glycol, an NSF approved, you would need to use dipotassium phosphate, and which means that you are not allowed to use a biocide in there. And that's probably the most important reason to maintain at least a minimum concentration of glycol, whether it's propylene glycol or in this case, detoxified ethylene glycol.
Okay. We're using about that range anyway, 20-25% or so for the most part. Larry asked the question, where are we able to source your product? Iowa, Minnesota, Wisconsin, and Illinois is where Larry works.
Okay, so we ship this all around North America to include Canada. Our facility's in Connecticut, but we do blend in Dallas, East Stroudsburg, Pennsylvania, Tennessee, and Ohio. So for many of the projects that we're working with, if it's a truckload, if it's 4 or 5 totes, it's drums. I mean, we typically, once the order's placed, it ships out pretty quickly. As we become more familiar in the geothermal space, recently had a distributor for geothermal products reached out to me, asked about warehousing and stocking those materials. You might be able to buy it from distributors, but currently you can buy it directly from us. And like I said, we ship all over North America and South America, certainly.
Okay. Anybody who's interested could send an email to info@IGSHPA.org and we'll provide Mark's contact info. Lucas asked the question, are there geothermal projects in the U.S. currently using this product?
That's a good question. There are not. And then, as I mentioned to Jeff earlier, we opened this facility 2.5 years ago. We primarily focused on food and beverage and breweries because that was what our initial interest was. Recently, I would say as recent as the last 4 or 5 months, we've had folks in the geothermal community reach out to us because they have found out about the product. So we had a company, Dandelion Energy, who is based in New York, who reached out because they wanted to standardize the use of Thermox DTX. So the first challenge was getting an approval from New York, which we just did, to use an ethylene glycol. Currently, we are working with Massachusetts, Connecticut, because Dandelion operates in New York, Connecticut, and Massachusetts. And so Connecticut, I expect the approval, probably I would say by the end of February, early March. And Massachusetts is just waiting for Connecticut. They have we've supplied all the data to the toxicologists and the hydrologists within those states. And I think typically with regard to Massachusetts, Connecticut, they typically follow suit with whatever New York is doing. And New York has just recently approved that. So it will take some time. The only thing I would say, Lucas, is that each state is a little bit different. I have found doing my research. There are some states that choose to write their own regulations. There's some states that follow the federal regulations, which do allow the use of ethylene glycol. And there are some states that are a little bit, it's kind of ambiguous. I'm not really sure what the requirements are. So if the requirement is to have a food grade glycol, this product meets that requirement because it is an NSF approved. If the requirement is specifically calls out propylene glycol, I would say that's usually what happens is I have to have a conversation with the hydrologist or somebody from the Department of Environmental Protection within that respective state. I usually submit the all of the supporting documents and information, and then this is no hit against the municipality or state government or federal. Typically in those type of organizations, it takes a little bit longer to, to move things along, but eventually they get through it. And then in the case like New York or some other states that we're communicating with right now, at some point they send us essentially either a waiver or a document that speaks to it that says that you allow Thermox DTX is now approved within that respective state. So that's probably the best answer I can give you, certainly. I mean, just lastly, I can send you, if you go onto our website, there are literally, I don't know, hundreds, if not probably nearing 1,000 of geothermal projects that we've done in the UK, large farm projects, large commercial buildings and residential. There are case studies there that you can read, certainly.
Okay, great, Mark. We have a bunch of questions coming in now, so we're generating some additional questions.
Excuse me.
Aaron asked the question, can the heat transfer fluid be changed in existing systems, maybe propylene glycol to Thermox? I've heard about issues with changing a system from salt brine to propylene glycol.
Well, the salt brine to propylene is a little bit different because, excuse me, you're going to want to clean that system pretty well. But with regard to moving from propylene to DTX, that's fine. Even these products are both miscible, so they do mix. We don't advocate certainly mixing propylene glycol with DTX, but if there is a small residual in there, that's not a problem. But with regard to salt brines, whether you're replacing the salt brine with propylene or in this case DTX, there is a cleaning process that because of the amount of sodium silicate or whatever that is in the brine solution, we want to make sure that does not mix with our inhibitor package. And so that's all I would say about that.
Okay. Thank you, Mark. Zach asks if loop conditioner is usable with this heat transfer fluid. You may not be familiar with that term, loop conditioner. It's been sold for a while. I guess from an IGSHPA standpoint, I hope nobody's using loop conditioner anymore. It comes from the pool and spa industry, and it's claimed that it was an inhibitor. People were using it in methanol, but I'm guessing, I don't want to speak for you, Mark, but because of the inhibitor package in this detoxified ethylene glycol, you probably don't want to add other chemicals, would be my guess.
No, and I would just say this. You're right. I'm not familiar with that. But whether it's an inhibited propylene glycol or in this case, inhibited ethylene glycol or DTX, the inhibitor packages are pretty sensitive, especially in this type of application, because if the state requirement is they have to have a food grade or food safe propylene glycol, that really limits the type of inhibitor package or any other chemicals you could add to it. We typically, most of our inhibitor packages are fully formulated inhibitor packages, either an inorganic acid or organic acid, which has chemicals like nitrate, molybdate, polytrizol, ethanoic acid. Those could not be used or probably would not be allowed in a geothermal application. I'm sure it's a case-by-case base with regard to each state. So more than likely, if their only requirement is food safe or food for incidental food contact, they're typically limited, at least all my research that I can find, to propylene glycol with dipotassium phosphate. There may be a small amount of polytrizol in there for what they call yellow metal, copper, and brass fittings, but that's you don't want to mix anything with our fluids or propylene glycol.
Okay, so we'd leave you would want to use the same inhibitors that are formulated in there.
Most definitely.
All right. Tom asks, many state and local jurisdictions require food grade propylene glycol. Is this product considered food grade?
It is considered food grade.
Okay. NSF,
So,
I guess, would indicate that.
NSF, right? Yeah. NSF is food grade. So it's under the HT1 category. excuse me, for heat transfer fluids. So what that says is that in the event this fluid was pumping through a system in a large refrigerated warehouse, and there was a leak, it was compromised, and a small drop was sprayed onto some vegetables. Uh, you certainly don't want to ingest this, but if you did, it would be safe.
Okay. Jay has a question. What percentage is necessary for 15 to 20 degree Fahrenheit freeze protection?
So 15, so you're looking at about a 21% concentrate of DTX for 15 degrees Fahrenheit. As I said, we typically recommend the lowest concentration we recommend is 22%. But if you're just looking at the pure number, if you wanted to protect to 15 degrees Fahrenheit, that's about a negative 9.4 Celsius. If you use propylene glycol, it's about a 24.3% concentrate. If you use DTX, you need 21%.
Okay. Could you add additional inhibitors to make up for
Well,
that
I will just
lower?
mention we have done it on a case by case. Nestle Foods, for example, they wanted an 11% system, which we never do really, but they're a big client. So this is the big system that I was mentioning earlier, 43,000 gallons. So essentially, we doubled the inhibitor package because of the sheer amount of water that's going to be in there. But let me just stop you there. We're allowed to use a biocide in there, and in this case, an inorganic. We would probably not be able to do that with a geothermal because all we're allowed to use dipotassium phosphate. Could we double the amount of dipotassium phosphate to use a lower concentration? I mean, theoretically, we probably could. We probably wouldn't do that because although you could add more inhibitors, that's not going to do a lot for the biological growth because we don't have a biocide in there. It's really the glycol concentration that provides that protection with regard to biological growth. So typically we will probably stand firm at a 22%. But just to give you kind of how it works, if you wanted to, I'll just give you an example. If you were trying to protect a minus 20, you would need Fahrenheit, that is, you would need a 47% concentrate of propylene glycol. And in this product, DTX, you need a 41%. So it's about a 5%, 5 to 7% less total volume system to achieve the same freeze protection when you compare it to propylene glycol.
Okay. All right. Very good. Terry has a question. Do you have tables for volume percentage versus temperature for adjusting pressure drop values? Also tables for volume percentage versus freeze protection.
Most definitely, Terry. And if Jeff, if someone wants to provide my email, I can send Terry those directly, certainly.
Okay. Yeah. Anyone can contact info at IGSHPA.org and we'll provide that contact info. I'm sure you have a website too where that would be available. Larry mentions Fernox products like F4 are a sealant product that's used in ground loop small pressure loss / fluid loss situation and is different than the old loop conditioner. So I think he's just clarifying an
Okay.
earlier comment there.
Okay.
So that loop conditioner isn't necessarily a good option in our industry today. All right, we have still about 15 minutes left. If anyone has any additional questions, we'll wait here just a little bit. But while we're waiting, thank you so much, Mark, for giving us some new insight here on different chemicals that may be available for our industry for heat transfer fluid. Is there anything that you'd like to add based upon the discussions that we've just had?
Well, the only thing I would add is I would just say to the folks that are listening, depending on where they're based, what state, I would just, and many of them probably already know the requirements, but you can certainly refer to the local department in your respective state in terms of acceptable fluids for geothermal applications. And if anyone is interested in considering the use of this, at some point, they could reach out to me. I'm happy to reach out to the state that they operate in. I recently had a large company from Wisconsin reach out to me who wanted to use it. So I have reached out to the folks at Wisconsin and supplied them information. Um, I'm optimistic. I think the conversation I had with them, they were happy that this was an NSF approved product, and they thought that they could probably grandfather this in, but I don't want to certainly speak for them. But anyway, I provided some information to them, and I'm happy to do that to any of the local municipalities that any of your members belong that operate in, certainly.
Okay. We just had another question pop up. Jeff asks, what is the percentage heat transfer loss compared to regular glycol? I think he's
That's a good
asking for
question. That's a
comparison
good
to
question.
propylene.
I don't know that, Jeff, and so I don't know. I don't have to get back to you about that. I don't know, actually.
Okay. Okay. All right. Well, I think we have had a lot of great discussions here, and once again, thank you so much for presenting, Mark. This will be recorded and should be on our website in the next couple of days. So go to IGSHPA.org, and you'll find under the media menu, town halls and dig deepers. You can look for that recording. And thanks everyone so much for joining us today. Hopefully this was helpful. And if you'd like to speak at one of these town halls or dig deepers, please go to IGSHPA.org and in the events and training calendar, and you'll find the abstract to submit there. We thank Climate Master for sponsoring this webinar, and hopefully everyone has a great rest of the week. Thank you so much.
Okay, thanks, guys.